Hello, we're in algebra. Today, I'll show you guys 3 ways to find the inverse of a 3 by 3 matrix. This right here is the example again. Why? Because we found the determinant of that matrix already last time, which is equal to 13, and that's not equal to 0. And that implies this right here does have an inverse, right? Keep in mind, not all the matrices have inverse. Sometimes you might want to compute the determinant first. Make sure it's not equal to 0, so you can do the following. Alright, for the first way, in my opinion, this is the easiest to remember. Not necessarily the easiest to compute, because none of this is easy, right? So I think it's going to take me 30 minutes for this video, but anyway, we'll just go. Alright, what we do is, here we have a 3 by 3 matrix. I'll just put that down, and together I will have the identity with it as well. So I will put down the 1, 0, 0, 0, 1, 0, 0, 0, 1. Also 3 by 3, and will pretty much form a bigger matrix. And what we wish to happen is, go ahead and just do the row reductions, and hopefully we can get this part right here to be the identity instead. So we have 1, 0, 0, 0, 1, 0, 0, 0, 1. That's our goal. Sometimes this might not happen because the inverse doesn't exist, but in this case we know it will happen, right? Okay, when this happens, we know that this side here is actually the inverse of the matrix. Now, perhaps the biggest question is like, how come this algorithm works? Well, thankfully I have Dr. Payam and he helped me with this. So this is the reason. When you put A and I together, and you are going to do a bunch of the row operations, and technically, whenever you do a row operation, it's just the same as multiply the matrix by an elementary matrix. And you can check out other video for that. Like for example, how can you interchange 2 rows? What matrix do you have to multiply, etc, etc. But anyway though, you do a bunch of the row operations. So you pretty much will have a bunch of the elementary matrices. When you multiply them, I'm just going to call that to be B, right? And then let's just go ahead and multiply this in. And you see, this right here is just going to be B times A. And I'm just put this down right here. And then this right here is just going to be B. Now, if this portion turns out to be the identity, what does that mean? You see, we have found a matrix B so that when you multiply with A, it gives us the identity. So that implies B has to be the inverse of A. There's a theorem for that. If you can find matrix B, multiply with A, get the identity, B is the inverse. Even though this right here is just the left multiplication, doesn't matter. Alright, so I think it's really cool. And now, let's see if it's actually really cool when you actually have to work it out. How are you guys doing? I don't know, but hopefully everybody's doing well. Let's see. Okay. So here we have negative 4, 2, 1, and then 1, 2, 3, and then 5, 1, 2. And then now we just put the identity right here, 1, 0, 0, 0, 1, 0, and then 0, 0, 1. Alright, so I want to have this entry to be 1 first. And we have 1 right here already, so let me just interchange these 2 rows. So the first thing that we have is we have the 1, 2, 3, 0, 1, 0. That goes first. And then I am about to put this down right here, right? But I want to make that entry equal to 0. So let me actually look at this and then multiply by 4. In that case, we get 4, 8, 12, 0, and 4. I'm just going to add this to that and then put it down right here. So 4 plus negative 4 is 0, and then this and that is 10, and then 13, and then 1, and then 4, and 0, right? So keep in mind this is the 4 because 1 times 4. Alright, now we want to make this equal to 0. In that case, I'm also going to use the second rule again, but this time we multiply by negative 5. So in that case, we get negative 5, negative 10, negative 15, 0, and negative 5. Alright, this and that together, we get 0, this and that, we get negative 9, this and that, we get negative 13, 0, and then -5 and 0, right? And lastly 0 and 1, so it's 1. So pretty good, we got the first column done. Now we want to make this equal to 1, but life does not have to be that hard. We do not have to divide it by 10, otherwise we deal with fractions. It's actually pretty lucky this time, because we can just add a third row to the second row. So have a look. The first row stays 1, 2, 3, 0, 1, 0, and then add this to there, so we get 0 and then 1 and then 0 and then 1 and then -1 and then 1. And here we want to make this equal to 0. So actually I can multiply everybody by 9 right here and add it to the third row. I will do that right here for you guys. Multiply by 9. We get 9, 9, -9, and 9. So 0 and 0 is 0, 9 and -9, and then 0 and -13, 9 and 0, and then this and that is -14, 9 and 1 is 10. So just like that. Okay, hopefully I can fit in everything to this whiteboard here. We'll see. Okay, now let me actually write down the last row first. But I do want to make this equal to 1, and unfortunately, we cannot avoid fractions. So go ahead, divide everybody by -13. And then we are going to put that down first. So here we have 0, 0, and 1. Oh, you see, the last row is going to be done already. And here we have -9 over 13. And then +14 over 13. And then -10 over 13. Okay, perfect. Now, this row is actually done as well, because we have the 0, 1, 0, so pretty good. So 0, 1, 0, and then 1, -1, and 1. Then we have to make this and that equal to 0. Let's make this equal to 0 first. To do so, I'm going to multiply the third row by -3. And you will see this is going to be -3. This and that is +27 over 13. This and that is -42 over 13. And +30 over 13. And then we'll just add this to the first row. The 1 and 2 will stay, so let me just write that down. -3 and 3 is 0. 27 over 13 plus 0, so that's right here. -42 over 13 plus 1, namely 13 over 13. -42 plus 13 is -29, and then still over 13. And then lastly, we have the 30 over 13 and then 0, so it just stay the same right here. Okay, whew, we can actually finish this in the whiteboard right here. I'm going to multiply the second row by -2. So that will give us -2 here, -2, +2, and 2. So, ladies and gentlemen, you will see that this right here, last row first, 0, 0, 1, -9 over 13, 14 over 13, -10 over 13. And then, second row, 0, 1, 0, 1, -1, 1. Okay, first row, 1, and then this is 0, and then 0. -2 is the same as -26 over 13, plus that is +1 over 13. And then this is +2, which is the same as +26 over 13. Adding with that, we get -3 over 13. Lastly, this is, oh, this is supposed to be -2, right? Because I'm multiplying -2 with 1. So this right here should be a -2. Thank God I kept that before I continue. 1 times -2 is -2, which is the same as -26 over 13. Plus that, we get +4 over 13. So, ladies and gentlemen, this right here is our inverse, right? So A inverse is equal to this matrix right here. Pretty cool, but again, you just have to run through the, yeah, all that stuff. Now, for the second way, maybe you hate it, maybe you will like it, I don't know. So I don't know, but I will show you guys anyway. The second way is that we are going to use the cofactors again. and I'm going to leave this on the board. Hopefully, we have the same answer. So this right here is the matrix A. I mean inverse of that. Right? And perhaps I'm going to just write that down right here so I have more space. So we actually got the answer. This is equal to 1 over 13, negative 3 over 13. And then 4 over 13, 1, negative 1, 1. And the last row is that, negative 9 over 13, 14 over 13, and negative 10 over 13. Okay, so that's what we have. So now I can erase this. Well, I will also remind you guys, remember the determinant of A, it's equal to 13. Okay? Okay, so here we go. This is the second way. Either you like it or you hate it. There's actually the formula for this, right? So it says the inverse of A, when this exists, this is equal to 1 divided by the determinant of A. And this is one of the reasons why that if the determinant of A is not equal to 0, you actually have an inverse. Right? You have the inverse. Well, what's this though? This is not it. We also have to multiply by the adjugate matrix. Yeah, ADJ. It's not adjacent. It's not doing trick right here, right? ADJUGATE, adjugate matrix of A. And now you may be wondering, what the heck is this thing, right? So I'm going to explain that to you guys. So let me write down the formula again. 1 divided by the determinant of A. But for this thing, what we do is we look at the cofactors and then we're going to form them into a matrix. So this right here, we'll just call that to be the cofactor matrix of A. That's not it. After you cut this, you have to take the transpose. What's the transpose? It's just that you flip the diagonal, just pretty much change the number here and here, and then number here and here, and number here and here. So, this right here, I don't know how you guys feel about this, but yeah, it's a lot of work for that. But anyway though, let me demonstrate the cofactor matrix of A first. So right here, I'm just going to use C for the cofactor matrix, and I'm just going to put it down right here. C is equal to, this is going to be a matrix formed from the determinant. How do we do it? This right here, right? First off, you have to remember what we did last time. Whenever we talk about the cofactors, we have the sign, right? Remember the sign that they alternate like this? So for the first entry right here, we have the positive sign, and then you go back to the original matrix, and then you are going to delete the first row and also the first column, and then you have the remaining part, this right here. And you're going to put that into a 2 by 2 matrix, and you're going to compute the determinant of that. So we have this, and then we have 2, 3, 1, 2. Right? So that's the first entry over there. And then next, we have the minus. So I'll put it here, and then I'm going to have the determinant of what? Delete this, delete that, and we have 1, 3, 5, 2. Right? Again, delete this, and then delete that, and we have 1, 3, 5, 2, like that. All right, and then just pretty much focus and do the rest. Delete this, delete that, we have 1, 2, 5, 1. And then here we have minus, and then we have the determinant. Delete this, delete that, delete this row. So we have 2, 1, 1, 2. And then plus, and then we have delete this, delete that, we have negative 4, 1, 5, 2. And then this is minus, and then we have delete this, delete that, we have negative 4, 2, 5, 1. Right? And here we have plus, And here we have, get rid of that, so 2, 1, 2, 3. And then minus, get rid of this, so we have negative 4, 1, and 1, 3. Right? Yeah, get rid of this, get rid of that, yeah. And lastly, we have the plus, and this right here is, so it's negative 4, 2, and then 1, 2. All right, so as you can see, we have this big, giant matrix right here. Man, so much fun, right? And you think we are done? No, we still have to find the determinants of all these guys. So, ladies and gentlemen, here we have the C. This right here is actually going to be what? Well, first we have positive, and just go and do it. 2 times 2 is 4, and then minus 3 is 1, so positive 1 right here. And then this is going to be 1 times 2 is 2, minus 15 is negative 13. Right? From the determinant. But because of the sign right here, negative times negative, you actually end up with a positive right here. So be really careful with remembering the sign matrix that I told you last time. Alright, for this, 1 times 1 is 1, minus 10 is negative 9, and just continue. Here, 4 minus 1 is 3, but that's actually a negative that you have to put it right here. And then this is negative 8, and that is negative 13. This is negative 4, minus 10 is negative 14, but you have the negative, so that turns out to be a positive. And then 6 minus 2 is 4, negative 12 minus 1 is negative 13, but again, negative becomes positive. Negative 8 minus 2 is negative 10. Yeah, just like that. And you think we are done? No. Now we have to take the transpose. This right here is just the cofactor matrix of A. Now we have to take the transpose. But for the transpose, we can actually do that together. So let me actually write it down right here for you guys. A inverse, ladies and gentlemen, this is 1 over the determinant of A, which is 13. So I will put that down right here, 1 over 13. And then let's go ahead and do the transpose of this guy. So open the matrix. The diagonal stays, so 1, negative 13, and negative 10. And then you are just going to change this and that. So this becomes right here, negative 3. This becomes right here, which is 13. Likewise, this and that you interchange, negative 9 and 4. Interchange, you get 14 and 13. So that's what we have. And you think we are done? No, we still have to multiply in the 1 over 13. So let's just go ahead and do it. So finally, A inverse. If we multiply this in, yes, we do get that, but I would like to finish this legitimately. 1 over 13 times this is 1 over 13. This times this is negative 3 over 13, 4 over 13, and then 1, negative 1, 1, and then negative 9 over 13, 14 over 13, 10 over 13. Whew, man. Negative, I'm sorry. Okay, so what do you guys think? Seems slightly faster, but again, I skipped the determinant part, right? We'll have a lot of determinant, but you have to just do a lot of determinants. Yeah, so I don't know, between first and the second way, I'm not sure which way that you prefer. But now, I wanted to show you guys the third way. Remember, when we find the determinant of the matrix A, we just copy down the first two columns, and then we do the diagonals, and then we subtract the diagonals, right? It actually has there's actually a similar format that you can set up, and you can actually get this pretty quickly, but you just have to remember the setup. I'm gonna leave that on because I want to show you guys this is actually the same thing as the little proof I gave you guys from the previous video. So here's the third way. It's just like a shorter version of the second way, right? So nothing too crazy. So I'm still going to use that. I'm still going to use the fact that A inverse is equal to 1 over the determinant of A times the adjugate matrix of A. which is equal to this part. But instead of doing all this, which will usually take you a while, go ahead and do the following. What you do is, you first write down A, right, which is negative 4, 2, 1, 1, 2, 3, and then 5, 1, 2. And just like what we did last time, yes, we are going to copy down the first two columns. So we get negative 4, 2, and then 1, 2, and then 5, 1. But not only that though, we will also then have to copy down the first two rows right here. So we get negative 4, 2, 1, negative 4, 2, and then 1, 2, 3, 1, 2. Okay, now check this out. What you do is, you're going to ignore, right, completely ignore the first row and also the first, so the first row and also the first column, like that. Maybe you can see already. 2, 3, 1, 2. 2, 3, 1, 2. Aha! And then what's next? This right here, it was 1, 3, 5, 2. But here we have 3, 1, 2, 5. So what do we do? Well, this right here might be better because when you do the following way, when you do it this way, you don't even have to care about the plus minus signs. You can just compute the following determinant that I'm about to show you. Alright? So, ladies and gentlemen, let me show you guys this part. And again, this right here, in fact, I will just write down the adjugate matrix for you guys already. Because by now you guys will see that the hardest part is, of course, this, right? But we can actually get it by looking at these numbers and then two determinants again. Have a look. First, you don't have to worry about the plus minus, plus minus. Second, you just have to go ahead, just block them. Like this right here is a square block, and then another square block, and then another square block. And you form the 2 by 2 matrix along the way, right? And then you compute the determinant. And if you would like, you can also do the transpose at the same time. So it's pretty cool. Have a look. Go ahead, I'm going to go across this row first. So do the determinant. 2 times 2 is 4, minus 3 times 1 is 1. So this is what we have. Yeah? So that's what we have. And then what we'll do next is, we'll do 3 times 5 is 15, and then minus 2, which is 13. But I'm not going to put it here. I'm actually going to put it right here. I'm actually going to put it down right here, right? And again, let's practice. And notice I don't have to negate whatever, doesn't matter. Let's do another one. This block right here, 1 times 1 is 1, and 2 times 5 is 9. That's the answer. Don't leave a comment, okay? 2 times 5 is 9 equal to 9. Anyway, 1 minus 10 is negative 9, and just write it down like that. And continue. Now block like this, right? So 1 minus 4, that's negative 3, right? And then next, negative 8 minus 5 is negative 13. And then 10 minus negative 4, which is actually plus 4, so that's 14, right? And you see we're done with that. And now let's see, 6 minus 2 is, why is that so hard? 4, yes. And then 1 minus negative 12 is actually positive 13. And lastly, this is negative 8 minus 2 is negative 10. Does this look familiar? It should, right? So, you see, if you do it this way, if you remember all the small things, this right here is exactly the adjugate matrix that we got earlier. Namely, you do all that, and then you take the transpose. It's just a very nice way. Just all the numbers worked out very nicely. The proof is pretty much the same thing as the one I showed you guys last time, but I think you guys can see that that's pretty much the proof. It's just a very nice way to organize all your computations. It's not like a new way. Yeah. Very nice. And then of course, once you have this, just put it back here and then do the 1 over determinant. So I'm going to leave that to you guys, right? So I show you guys 3 ways. Leave a comment down below and let me know which way that you like the most. Anyway, as always, that's it.